to 2 because we've taken 2 steps. So this will be x squared plus 2xh plus h squared. Now, what if we don't know what n is? If we look at it, then we have a small pattern. Every single number here is going at the start is going to be 1, and then the layer. Because if we add our bricks, we can ignore these bricks, but keep on adding here. So it'll be 1, and then 5 for the 5th layer, and then 1 and 6 for the 6th, 1 and 7 for the 7th. And so when we expand, our first two terms are going to be x to the n, and then plus n times x to the n minus 1, h to the 1. After that, we'll have terms that have some constant at the start, and then times x to the n minus 2, h to the 2. But we can actually kind of ignore these terms, because if we put this into our limit here, what will happen is we are going to have the limit as h approaches 0 of x to the n plus n x to the n minus 1 h plus some constant x to the n minus 2 h squared, and then so on and so forth, and then minus x to the n from here all over h. Now, this x to the n and this x to the n will cancel out because it's plus x to the n minus x to the n. And now we can divide every single one of these terms by h, because there's a h in each term and we're dividing by h. So this will be the limit as h approaches 0 of n x to the n minus 1 plus some constant x to the n minus 2 h, because we would just knock 1 off the power, and then so on and so forth, but they will all have a h term in them, and because h approaches 0, every single other term is just going to be equal to 0. So it just becomes the limit as h approaches 0 of this, and because we don't have any h, it just becomes this. So the derivative of some term x to the n is just n times x to the n minus 1.